Today we're going to look at nodal analysis and mesh analysis, which is what it looks like your homework is on, homework 4, those kinds of questions. And if you have additional questions, please feel free to ask. So does anyone have anything they want to ask before I get started with these problems that I have on the worksheet, which is kind of give the idea of how you do these kinds? Any questions before we get started? Yes?
Are we also going to have time to do some of the homework problems too?
Not the exact homework problems, but things like the homework problems, yes. And I take it that's what you want to do?
Yeah.
Okay. So yeah, I will try to make sure that we have time to do that. And to do that, I might just do 2 of these instead of all 4. But and these will be to give us the idea. So this first one, it looks like, I bet I made this in 2020, because in the fall of 2020 I broke my arm and I had to do things left-handed, and so this looks like it was a left-handed drawing here, so that's when I think I probably made this one. All right, so what a mesh is are two, it's 2 regions that share a current, and they're like panes on a window. And what you would do is you assign mesh currents to each of the meshes, and you also, when you assign them, you give them a direction as well. And so you do them with a little loop. And I think it's best to always do your loops in the same direction. It doesn't really matter, but it's, if you do them always like all clockwise or all counterclockwise, you'll just be consistent. And so that's my first mesh, and I'll call that I1. And this is my second mesh, and I'll call that I2. And the deal with a mesh is that any current that's in one of the branches that's shared by 2 meshes is really a combination of your mesh currents. So, and it's always going to be one minus the other. So if I do them all clockwise, then that means that any current through a branch is going to be one of the meshes minus the other mesh. So in this example, I would have that the current going down that middle one. Well, if we look at I1 is going down, but I2 is going up through that branch. So the current down that middle branch equals I1 minus I2. So after I find I1 and I2, then to find I, which is what the question is asking for, then I will equal I1 minus I2. Now the way mesh analysis works is it uses KVL. So we add up the voltage drops going around our mesh. And if the current enters the positive terminal of a voltage source, count that voltage as positive, and voltage drops across resistors will be your mesh current times the resistance value. And since we drew the mesh current, we drew it clockwise. As we go around with our KVL, we should go clockwise. And that means that all of our voltage drops across the resistors will be positive, because we'll have I I1 or I2 is drawn as positive, and then be multiplied times the resistance, which is positive. So as I'm going around this first loop here, I go into the negative side of the 12-volt voltage source. So that's negative 12. So voltages are just whatever number they are. You don't use mesh analysis with current sources because unless you know what the voltage drop is across the current source. We can use it here because we know what the voltage drop is across a voltage source. So it's minus 12, and then plus 4I1, and then plus, and then our middle resistor right there is 3, but that's going to be I1 minus I2, because any of the branches that are shared, it'll be the mesh current on the loop that you're looking at minus the other one, because the other one should always be going in the other direction. And then plus, and we have this 2 ohm right here at the bottom, 2I1 equals 0. And then on the branch on the right, I'm going into the negative side of the 4-volt voltage source. I'll be negative 4. And then plus, and then I've got the middle branch there. That's going to be 3 ohms times my current, which is I2, minus the current going in the other direction, which is I1, plus 5I2 equals 0. And then if I simplify this, y'all keep an eye on me here. So this is 4 plus 3 is 7 plus 2 is 9, which does not look like any of my choices here. So oh, because I don't have this problem worked out. Okay, yeah. All right, so it's 9I1, and then minus 3I2 equals 12. Y'all stop me if you see a mistake. Does that, okay. And then the bottom equation, minus 3I1 plus 8I2 equals 4. And then I can divide this top equation by 3. And I get 3I1 minus I2 equals 4. And then if I add these two together, I get 7I2 equals 8, or I2 equals 8/7 amps. And then I'll plug back into this second one here. 3I1 minus 8/7 equals 4, or 3I1 equals 36/7, or I1 equals 12/7. All right, and then so the problem is asking for I, and at the very beginning we saw that I was I1 minus I2 the way we have them drawn. I is I1 minus I2, and I1 was 12/7 minus 8/7 is 4/7 amps, or 0.57 amps. So I'm just going to check myself here. So if it's 0.57 amps, then that means the voltage drop across this resistor should be 3 times 5/7, or 3 times, what did I just say it was? 3 times 0.57. 3 times 0.57. Or 1.71. which means that if the current is going down is positive, and I get 0.171, that means this side has to be 1.71 volts more than this side. And so if I make this ground, then that would be 1.71. Now if this is ground and I have my 4-volt voltage source right here, and ground has to be 4 volts higher, so I've got the plus on this side, that means it has to be -4 right there. And so the current going this way, it means I2 ought to equal 1.71 minus -4 over 5. So 1.71 plus 4 divided by 5. And then what did I say? I2 was 8/7. 8 divided by 7. Okay, there we go. So it did work. So that was just my little check for myself. So I absolutely did not have to do that last part. That was just a way for me to verify that what I had done was correct. Any questions on that? All right. Yeah.
Question, but it's not really related to the problem.
Okay, well, let me stop this.